Hey y'all, this video is going to be going over heat and heat exchange problems. In other words, the Q equals MC delta T problems. So follow along with this video if you're struggling with that kind of algebra-based problem. So in these types of problems, as I say up on the top, you'll be provided with 3 of the variables in the problem, and your job is to use algebra to solve for whatever the missing variable is. For example, in this first question, it says how much energy is required to heat 1 kilogram of water from 5 degrees Celsius to 15 Celsius. So the first thing that I'm going to take note of is that it's asking me how much energy, which means I'm looking for Q. What I want to solve for is Q because Q represents energy. Then, to set up this problem, I'm going to set up my variable as Q and set that equal to MC delta T. So my M, my mass, is 1 kilogram of water. In other words, 1,000 grams of water. Because I'm working with water, that's a specific heat that I know, which is C. And the specific heat for water is 4.184 joules per gram degree Celsius. That's a number that I have memorized, and I suggest that you memorize it too. And lastly, my temperature change is from 5 Celsius to 15 Celsius, and so my temperature change is the difference between those numbers, which is 10 degrees Celsius. Now to get my Q value, all I'm going to do is plug those 3 numbers into my calculator. 1,000 times 4.184 times 10, and that gives me a Q value of 41,840 joules of energy would be required. Now, if I was worried about sig figs for this problem, which I should be, technically I only have 1 sig fig available to me in this problem, so my answer would be 40,000 joules if you're worried about sig figs. Next. What is the change in temperature when 15 grams of tin with a 0.21 specific heat capacity is heated with 5,245 joules of energy? Okay, this time I am asked for the change in temperature, so I'm going to be solving for delta T, and I should have all my other variables. My Q is going to be how much energy I have, which is 5,245 joules. My M is the mass of my substance, which in this case is 15 grams. My C, which is my specific heat capacity, is 0.21 joules per gram degree Celsius, and I'm looking for my delta T, which is my change in temperature. So to solve for this problem, I'm going to take these 2 numbers, 15 and 0.21, and I'm going to multiply them together. And then I'm going to take 5,245 and divide that by my mass times my specific heat. So I'm going to plug that into my calculator now. 5,245 divided by 15 divided by 0.21. And that gives me a delta T of 1,665 degrees Celsius. Now, this is a big number. It's probably not so realistic that your numbers would be as high as this, but if they are, we can be confident in our answers, and that's okay. My next problem asks me for the mass of brass that would be required to raise from 25 to 37 Celsius when 1,500 joules of energy are added to it. So I'm asked for a mass, and so that's what I'm solving for. My Q value is my joules. That's 1,500 joules. My mass is my unknown variable. My C value is 0.380 joules per gram degree Celsius. And my delta T is 12 degrees Celsius because that's the difference between 25 and 37. So again, just like the last problem, I'm going to take 1,500 divided by 0.380 and take that number and divide it by 12. And that leaves me with my answer in grams, which is 328.9 grams. Again, if I'm worried about sig figs, I'm going to look and see that my fewest are 2 sig figs, and so I would round that to 330 grams. Technically, my lowest is actually 1 sig fig, but we're going to assume that it's 2 for this problem. And lastly, another Q equals MC delta T problem is asking for a specific heat of an unknown metal. So I'm going to be calculating a C value. And to do that, I'm going to take my Q, which is 12,000 given to me in the problem. I'm going to take my M, which is 20 grams of that metal, so 20 grams. My C is what I'm solving for, so I'm going to leave that in parentheses. And my delta T is 67 degrees Celsius because I have raised from 10 degrees Celsius to 77 degrees Celsius. To figure out what my C is, I'm going to take my joules, 12,000, divided by my mass, divided by my delta T, and that gives me a C value of 8.96 joules per gram degree Celsius. And if I'm worried about sig figs, I'm going to round this to 2 sig figs because that's what my answer gives me. So I would round that to 9.0 joules per gram degree Celsius. All right, those are your Q equals MC delta T problems. They're really algebra-based problems where you're solving for X given one variable that's missing. Thanks.